Hello, everyone. Let's try this again. Screencastify is giving me a hard time today. So today we're starting chapter unit 10, unit 8, which is graphing quadratics. So our generic quadratic is y equals ax squared plus bx plus c. These notes I'm writing just on page 2 that's blank in your packet. It's important that you memorize ax squared plus bx plus c because we're going to use a, b, and c in formulas. So our parent function is y equals x squared, which looks like this first graph I made here. And why this is important is we need to know this point down here at the bottom is our vertex, which is our turning point, and that's a minimum. If we have y equals negative x squared, then our vertex is a maximum. Now, what determines which way the parabola opens is A. If A is positive, then it opens up, and I call it a happy parabola. If A is negative, then it's a sad parabola. It opens down. Now, parabola is what we call these graphs. Now, we do need to know a couple other key points for a parabola at this point in time. Oops, scroll too much, sorry. So if we look at this graph, which this is the graph of the function y equals x squared plus 5x, minus 5x plus 6. And when we look at this, we see that it has a minimum, but it also has these 2 points right here, which are the point 6, 0 and negative 1, 0. Those points are called our x-intercepts. They're also called our roots. They're also our solutions. And they are also our zeros. So those points are important. And then the last point that's important is our y-intercept. Our y-intercept on a graph is wherever x is 0. And so that always corresponds with c. Our x-intercepts are when y equals 0. So those are important things from there. So now we're going to start our actual notes. We start on page 2. And there we go. So 8.1, graphing quadratic functions. A parent graph of a quadratic function is y equals x squared. Graphs of quadratic functions have a general shape called a parabola. Parabola opens upward when it has a minimum point, which is when A is positive, and opens downward when it has a maximum, A is negative. So to graph y equals x squared minus 4x plus 1, we're going to use our graphing calculator. So we go to y equals, and then we're going to enter x squared minus 4x plus 1. And if we hit graph, we can see what that looks like. To graph it on our paper, we should use our table. And I want to always see where the vertex is. So you can see here at our table that our vertex is at 2, negative 3. So I write those points down in my table. So 0, 1, 1, negative 2, 2, negative 3, 3, negative 2, and 4, 1. We plot those points. And then we connect with a smooth curve. And our point down here is our vertex, which in this case is a minimum. Our domain has all real numbers for x, which is negative infinity to infinity. But our domain, our range, only goes down to to our vertex, which is a minimum. So it starts at -3 and goes up to infinity. Remember, when the value is included, we do this closed bracket. So it's from -3 into infinity. You could also write that as y is greater than or equal to -3. So now we're going to graph our next one. So again, I go to y equals, I'm going to clear that one out, and I enter -x squared minus 6x minus 7. We take a look at it, and you can see that this one goes down. So then I look at my table, and I'm looking for where it changes. So you can see that as I go up, the values are getting bigger. Oh, and now they start to get smaller. So I want to make sure I include that turning point, the vertex, in my graph. So I'm going to start with -5, -2, -4, 1, -3, 2, -2, 1, and -1, -2. I'm going to plot those points. -5, -2, -4, 1, -3, 2, -2, 1, and -1, -2. And I connect with a smooth curve. Oops, that wasn't very smooth. Oops, I'm not on eraser. Sorry about that. All right, try again with my smooth curve. And those mistakes are why you definitely want to make sure you're using pencil. So again, my domain is all real numbers. My range this time is all values is y is less than or equal to 1. This should be a negative, or less than or equal to 2, sorry. So y is less than or equal to 2. So I'm going to, I can say y is less than or equal to 2, or that means it starts at -infinity and goes up to 2. So I want you to pause. I want you to try the next 3. Okay, so number 1, I plotted my points with my table that I got from my calculator. My domain is -infinity to infinity. My range is 2 to infinity because it goes down to 2 and continues up. Has a minimum. Number 2 has a maximum. So again, I made my table, plotted my points. It's -infinity to infinity, and the range is -infinity to -4, -4 included. Number 3, I paused. So number 3 is what I have on my calculator here, and you can see that I have 2 zeros in the y, but I don't clearly see a turning point. So what I want to do on my calculator is I want to go down to 1, which is where that repeat is. I'm going to hit plus. And what plus does is it brings up this triangle TBL. That means change in table. So if I make my table go by a half, you can see then I have the point 1.5, which is -0.25. So that's actually really my turning point. And in tomorrow's video, we're going to learn a better way to find that. But for now, that's what we want to do. So now I want to plot those points. Because if I didn't find that, I have a flat line on the bottom. And all parabolas have an exact turning point. And it's my job to find those as the person who's graphing it. I plotted that point wrong, sorry. So that's 1, 0. And then it's the point in between. And then 3, 2. So this goes like this, and there's my turning point just below the x-axis. So my domain goes -infinity to infinity, and I had to find that turning point so that I knew where it starts. So it starts at -0.25 and goes to infinity. And that's the end of our video for today. If you have any questions, please ask in class.